Good afternoon or good morning if you're joining us from BC. Welcome to our webinar today. We're thrilled to presenting case studies from Zoo House and HSS Design Build. Also very happy to have some representation from SSRIA, the Smart, Sustainable, Resilient Infrastructure Association. My friend Alex is helping co-host today's webinar. SSRI is a close partner and a previous funder of some of our work. Just a reminder to everybody that this session is being recorded. And today I just wanted to acknowledge that I am joining this meeting from Treaty 6, and this is land that is important to many First Nations and Indigenous people and Métis, members of Métis Nation. And I feel privileged to be here, and I do feel like the work that Retrofit Canada does and our guests here today are doing is a part of taking care of the environment and stewarding it. And we're just want to acknowledge that. So start with some introductions here today. We have Adam Larson from Zoo House. We have Joe Hopkins from HSS Design Build. And we also have Peter Amarangan, who is one of the co-founders of Retrofit Canada. And he is also a pioneer in deep retrofits. And then finally, we have Alex Joseph from SSRIA. Retrofit Canada, we are open source. We exist to collect knowledge about completed deep retrofits across the country and beyond. Our goal is to find the best approaches to doing deep retrofits, share solutions that have worked on completed projects, find ways to eliminate the barriers that exist to getting deep retrofits done on the scale that we need to eliminate emissions in Canada by 2050. And our goal through this work, through partnering with people like Adam, Alex, and Joe, is to just find ways to accelerate the pace at which retrofits are happening. I want to acknowledge our funders. So Retrofit Canada, as part of the Greener Neighborhoods pilot project, is funded by NRCan, the Government of Canada. We have also received funding from Alberta Eco Trust. They have helped us do some really great work. And again, as I said earlier, SSRIA has also been an important partner and helped support different aspects of the projects that we have undertaken since we started operations in 2020. So again, these are today's guests. But at this point, I want to turn this over to Alex, and he's going to take a couple minutes just to share some information about SSRIA. So over to you, Alex.
Great, Tim. And the in the Zoom, the slide control just turned off, so I may have to get you to advance the slides. Oh, it's back.
Fixed it.
So yeah, welcome everybody, and thanks Tim and Retrofit Canada for collaborating, allowing us to collaborate on this webinar. As Tim said, Alex Joseph, the QR code there will I believe take you to the SSRIA website. I'm the program manager for the Innovation Fund, and the Innovation Fund really funds demonstration of low carbon solutions in buildings across Alberta. And we're in our second round of that now. And the two projects presenting today are part of our Innovation Fund portfolio. What is SSRIA? Beyond an acronym that is perhaps challenging to remember and pronounce, really our vision, similar to Retrofit Canada, is to revolutionize design, construction, operations of buildings across Alberta, really with that goal to reach zero carbon in the built environment by 2050. Unlike Retrofit Canada, we're focused not only on the retrofit side, but also on the new building side. So really our mission is to accelerate adoption of innovative low carbon solutions in buildings. And we take a variety of approaches and tactics to do that. So We facilitate collaboration. And so in this case, this is a great example working with Retrofit Canada, specifically on in the retrofit space, connecting with experts, visionaries. We support innovative business growth. So some of the companies that pass through our programs require additional support beyond the low carbon solution piece. And so we have some programs that support the growth of their businesses in Alberta. We support knowledge and expertise hubs. So the work that Joe and Adam are doing on both of their projects ultimately will end up, some of that information will end up on our website and available to the wider community. And ultimately, the Innovation Fund, of course, funds the demonstration of these and validation of these solutions, to which you're going to hear more about from Joe and Adam today. As I said, we're in the second round of Innovation Fund, and through the first round in the last sort of 4 years plus, we've demonstrated 38 different technologies. Our project teams have in 48 buildings or more across Alberta. These span envelope, mechanical systems, renewable energy, battery storage systems, and also grid connection, different technologies. It's residential, and of course, the two projects today are residential retrofit, but SSRIA supports projects across commercial, institutional, and industrial as well. And as I said, both retrofit and new construction. To date, our projects on average have saved 62% energy, operational energy. And also, we've saved 8,000 tons with the specific demonstrations. But with the replicability and scalability of those projects, we project 200,000 tons of carbon savings or greater. And that, of course, doesn't include these most recent projects that'll be talked about today. So previously, we had 20 Innovation Fund projects that passed through the SSRIA Innovation Fund process. You can find more information about those either through the QR code on the screen or by visiting our website. And the two projects being talked about today now form part of the portfolio of 13 plus new projects that are demonstrating low carbon solutions in buildings across Alberta. So with that, maybe back to Tim.
Thank you so much, Alex. And we actually have several projects already in our case study library that are where we had some of the research and development funded by SSRIA. Very thankful for that. And I know that both Joe and Adam have promised me that we're going to get these case studies into the library. So they're going to present them today, and we'll get them in the near future. So we will start with Joe and HSS's project. Joe, I'd like to invite you just to make sure you start with a bit of an introduction. I will confess that I chose the wrong setting for sharing the slides, and I could not see my notes on your bio. So I just want to give you a moment to talk about how awesome you are. And then
Okay.
Adam, after he's done, it would be great if you could do the same. So Joe, I'm going to stop sharing, and I'll let you take it away.
All right. Okay, so you should be seeing my slides there. Yeah, so my name is Joe Hopkins. I've worked for HSS Design Build for a little under a year now. I have a degree from the University of Calgary in architecture and did environmental science stuff before that. HSS Design Build was founded in 2016 by Raf Spinner, and his vision was to accelerate the transition to sustainable and energy efficient design and construction practices in Western Canada. We do all high performance buildings. In the time that I've worked here, we've never done a regular wall system. They're all high performance walls, sustainable materials, and all that sort of stuff. And then we also do a lot of deep energy retrofits, which is what got Raf interested in this pier system that I'm going to speak to you guys about here today. So the big kind of problem that we're thinking about with this pier system, first this pie chart on the right, the built environment is a large portion of greenhouse gas emissions in Canada, and you can break that down into building operations as well as building construction. And then this pie chart on the left-hand side there is kind of this idea you hear that 70–80% of the buildings that are going to be here in 2050 have already been built, and most of them are performing poorly. So we need to address the energy performance of these buildings, and then we also need to keep in mind that if you just tear them down and build new buildings, you're just moving building operations carbon to building construction. So that steers why we're interested in retrofits and some of the materials we work with. Because retrofits, you can retrofit an existing building to perform as well as a high performance new building, and you have a fraction of the embodied carbon. So that's kind of the big overview of what got us interested in PURE. So PURE, starting from the bottom there, we retrofit your existing building to dramatically improve energy performance. We do that by wrapping the exterior with insulated panels that we prefabricate offsite. There's a bunch of advantages to PURE listed on the right here, from reduced greenhouse gas emissions and occupant comfort and utility bills and all that sort of stuff. So this is our panel system. So starting on the left there, number 1 to 4, that's your existing wall. One important feature of our panel system is that we kind of still use that existing poly that's on the interior of your house as the air vapor barrier, and then we do things to kind of try to improve the air tightness as we work our way out. We strip all of the sheeting off the exterior of the building, or all up down to the sheeting, and tape those seams. And then we put these PURE panels on the outside. So number 6 to 8 there, that's what we prefabricate offsite. It's a 2x4, 2x6 stud wall with a wood fiber, rigid wood fiber product on there that I'll talk about in a minute, and then vertical strapping on there. So that's prefabricated. We fix that to the existing house, and then we blow in, number 5 there is blown in wood fiber. We dense pack it in there, and that's essentially the panel system. We use the first wood fiber product we use is this rigid wood fiber board. It comes in a variety of thicknesses. It's tongue and groove, R value of 3.7 per inch, and you can cut it with regular tools. Super effective product to work with, and we use it on all of our projects. The other product is this blow-in insulation. We dense pack it into walls, which is that's a little test box on the right there that we blew full of wood fiber and then pulled the top off it to make sure we were getting the right density and there were no voids. And then on the left is a picture of an attic that we blew, I think, about 14, 16 inches of wood fiber in there to improve the attic insulation. And we like working with these products because the environmental product declaration, if you compare that to any other insulation product, they're far better for the environment. They're natural and renewable, and they perform as well as most other products as an insulation, and then have some other benefits on top of that. One of which is sequestering carbon. So all these natural materials sequester carbon, where other products you're emitting carbon to produce them. So it really addresses that front end carbon, embodied carbon of the retrofit component that I was talking about at the beginning there. And then wood fiber, because trees move water, wood fiber is also good at moving water, and that means that it's excellent at drying, which is why we're able to put this on the outside of your existing building that might have some leaks in the poly, in that air vapor barrier, and it's going to dry to the outside. We know people are sometimes uncomfortable with that or unfamiliar with this product, so we've put a bunch of sensors in the walls and around windows and stuff like that to measure temperature and relative humidity. So that picture on the left there, you can see there's a sensor on the wood fiber, there's a sensor at the center of the blown in, and then that wire I'm holding is going to be screwed to the existing sheeting of the house to measure moisture content of the sheeting. So we know that is going to be drying to the outside, and that contributes to long-term durability. We've also sent a panel off to Ottawa to be put into a weather chamber, and it's going to be subjected to a bunch of weathering events, and there's a bunch of sensors in that we'll be monitoring as well. So we're confident that we can speak to the drying capability of the wall system. So this is the pier process in a nutshell. Essentially, we go out and scan your existing building. We convert that into a point cloud. That point cloud gets converted into a building model, which we can then use to design panels to wrap around it and then install on the building to improve the energy performance of it. So I'm just going to go through kind of that process and talk about some lessons that we learned along the way. So building scanning, you go out with some scanner and go around the building. We like these 360-degree scanners where you go and set it up a bunch of places around the building, and each one collects a point cloud, which we can then stitch together and get a highly accurate point cloud. So we tried a few different types of scanners. The first one on the left there was a handheld one, and it wasn't super accurate. So we didn't find it to be super effective. The second one was this Faro brand one, which was the point cloud was accurate. The problem we had with it that our TC360 addressed was that the Leica connects to an iPad, and as you're scanning the building, you can look at your scans on the iPad and make sure that everything's lining up. And if there's any places you've missed, that shows up, and you can go back and get it. So we found the functionality of the Leica system to be effective, and then this point cloud is accurate within 3 mils. And we can rent one of these for quite a reasonable price and probably scan. We've done 2 in a day, and you could probably scan 3 buildings in a day. And then we also like having it on that big extendable tripod there, because sometimes you can extend it up to get above a deck or above a roof line or something like that. So that's been quite effective for getting point clouds. And then what it produces is a point cloud that looks something like this. This is the project that we're working on right now, and we ran around it and scanned it, and that's what that's kind of our working point cloud for designing and modeling the building. And an important component of that is getting the rough openings for your windows. So this is a close-up of that point cloud, and then we're able to identify where the windows are supposed to be on that wall, and then we build those into the panel. A challenge we've had with that is, so this picture on the left here, this window, actually in the rough opening, it was pushed all the way to one side. So that kind of throws off your point cloud a little bit. But what we did is we designed our panels to have slightly smaller windows in it. So you can see on the outside of that picture, you can see the panel is on there, and then the other picture is from the inside. So despite it being off from the existing rough opening a little bit, we were able to fur that out and still put the window in there without any hassle. So that's a nice little detail that gives us a bit more wiggle room in the grand scheme of things. And so this is kind of what it looks like. If you compare that green part, which is the prefab panel, to the red part, which is the existing, we just designed that. We designed that panel to be a little bit smaller, to give us that wiggle room, and similar on the section cut. We need room for positive drainage to get water away from the window. So that's the bottom of that panel is a little bit lower as well. Yeah, and so then we created this digital model, and that's what the panel, that's what the panels are built off of, and has all your windows and doors and rough openings on it. There's some kind of ground truthing with measurements and stuff like that are important to go along with that. And then we design our panels off this. So we use a program called CADWorks that we can design these panels with. It shoots out drawings and cut lists and all that sort of stuff. And that's all been quite effective so far. And then prefabrication. So we have a framing table. a cut list. Everything gets cut to length. We throw it on the table, and this is Brock. He's a carpenter who works for HSS, and he can have a panel like this together pretty quickly. Interesting lesson on this is our prefab facility is pretty basic at the moment, but even this, just having a good workflow set up and a basic framing table, you can really put together panels quite quickly. And I think a lot of people think that you need these big fancy facilities with a lot of automation and stuff, and a little bit goes a long way. So I think that's an interesting point for people to think about. Like, you don't need a multi-million-dollar facility to do that. Site preparation. So we strip off all the existing siding, right down to the sheathing. We tape the existing sheathing, and we put our ledger around the bottom, and that's what supports the panel system. So this is our second project, and there you can see some pictures of the ledger, some of the air sealing that we do on the existing sheathing, and then we use EPS kind of at the below ground level there. Yeah, you can see this is quite a tight site and a narrow lot, so there's been struggles with scaffolding and all that sort of stuff, but all in all, it's been pretty effective so far. Panel installation.
Joe,
yeah.
Tim, there's some background conversation coming in.
Oh, okay, sorry. Okay, Chris, can you keep it down? Thanks.
Chris. Okay,
I wasn't sure how much was coming through on the mic. Sorry about that. So yeah, panel install. We have a crane show up, park it beside the building, back the trailer in, and fly panels in. This part happens pretty quickly. Sometimes we have to get a little bit more creative when we're putting them in, but yeah, it's worked, and you know, your rough openings, you're always hoping that they line up and they go on, and in both cases they've lined up close enough that we've been able to put panels on. So that's been effective. And then this project here is, 3 stories high at one point, so there's a lot of high up work going on with this one. And then window and door install. So like I said, we're keeping that existing poly as an air barrier, so it's important that you tie that into the new windows. So on this project, they wanted windows right at the outside, so we had to bring that poly around and tie it into the window. If you look closely, you can see this had a 2x4 wall, and then there's we put an 1.5 inch gap that allows the building to wiggle the way if it wasn't built straight or whatever. And then our panels are exterior of that. So this one, the windows are on the very outside. This project that we're working on now, the windows are going to be located more interior. And the interior of the house had an interior renovation, so we're trying to minimize damage inside there. So we just tore back that drywall to expose a bit of the poly membrane there, and then we could get a hold of it with some tape and bring it around. And then we're able to effectively tie into that barrier. When the window goes in there, there'll be some more tapes and stuff like that. But we've had really good luck with air tightness so far around the windows and stuff. And then the blow-in wood fiber goes in. So it's, we drill a hole in each cavity, put a hose all the way to the bottom, and dense pack wood fiber in there. Oh, sorry. At high density, so it won't settle. And then after the fact, we go around with tapes and tape up all the holes. And yeah, we started doing this ourselves, and it's worked well. We also do a similar thing in the attic. So we had access to the attic in this case, and we got up there and blew a bunch of wood fiber in there, which then adds to your insulation in the attic. You do get, where the roof comes down to the eave there, it is a little bit thinner there, but all in all, it's a relatively cost-effective way to address the attic without having to spend a whole bunch of money. And then finally, we have finishing. So this project, siding went on and the deck went back on, and we had changed out the furnace. So there were some new penetrations out the side and all that stuff. But all in all, it looks similar to what it did before, but better, and performs a lot better energy efficiency wise. So that project there, we had EnerGuide evaluation done before and after. So to compare the data on that, we went from 126 gigajoules per year of energy use to 67 gigajoules a year, and 11.6 tons of greenhouse gas emissions to 8.4. And then if you look at the pie chart at the bottom, we addressed space heating was the only thing that we addressed. And we took that from 66% of the heating load down to 34%. So pretty effective. And then another way to look at this is this table on the right. The only thing we addressed is space heating. So water heating and electrical, that usage all stayed the same. We did add some ventilation. But we took space heating from over 80 gigajoules per year down to something like 20. And then another thing that's shown in the EnerGuide evaluation is where you're losing heat from. So I'll just go through this a little bit. So we had a dramatic improvement on the windows, which is good. The old windows were really old, so we did see really good gains there. Air leakage is the figure that we would like to have seen better. That's still quite a bit of air leakage there. But this project had a crawl space underneath it that we didn't really get in to address. And when we did a blower door test and went around with a smoke stick, all of the air, there was no air coming through the attic or the walls or windows or anything. It was all going down into this vented crawl space. And for a few reasons, we weren't able to get in there and do work, but I think it's going to happen in the future. And when it does, that air leakage will go down significantly. We're confident with the detailing. We tape everything when it comes through the sheathing and through the wood fiber. This project we're working on now, when it's done, we're going to do a blower door test, and it'll be a good indicator, better indicator than this project of the success of that. Walls here, we had dramatic improvement in energy loss, heat loss through the walls, and we only actually did 3 walls. There was addition that's going on here, so we addressed about 80% of the walls. So we could have reduced, and even now the addition is going on there, so that performance will be better. Yeah, so some other lessons we learned. Site framing, a lot of buildings have these areas where there's just a bunch of penetrations coming out. You have hot water and heat, and in this case, there's a heat pump there. And so what we did is we just framed out a hole in a panel, and then that makes it easier. You can, get your trades to come and do what they need to do to get out of the way, get the heat pump out of the way, something like that, fly the panel in, and then this gets site framed later. Same thing with utilities, electrical and gas. Those guys don't tend to show up exactly when you want them to, so frame it out. They can come, move their stuff, and then frame it in after the fact. Yeah, and then I guess what's next for us, we're kind of interested in attempting a multi-unit residential building. We think it has a lot of potential there, repeatability and stuff like that. So we're looking to find some folks that are interested in something like that in the future. And again, if anybody out there is interested in doing this, we've learned a lot of hard lessons, and we are a design build outfit. So, we do all the work, or we can do all the work, but we're also quite happy to consult about buildability and all that sorts of stuff. So if you have questions or you're looking to do one of these projects and you're a little bit intimidated by it, we'd be happy to help out in any way that we can. We're interested in this becoming more common. So do reach out. And again, finally, thanks to SSRIA and IFIT who funded this project and made it possible. We're very appreciative of that. Yeah, so thank you. And then that's it for me.
Thank you, Joe. Just a reminder to everybody, we will be doing a Q&A at after Adam has done his presentation, and I did put a note into the chat. Please use the Q&A widget in your Zoom toolbar. It's the speech bubble with a question mark. You can submit your question, and you can also vote on questions that you want to see answered first. So Adam, it is now over to you.
Having a little bit of difficulty here. Just give me 1 minute.
Yep, no worries. I have put everybody, Adam and Alex and Joe's the websites to their organization are in the chat. If you want to take a closer look at what they do and what they've been up to and some of their other projects.
So it says I'm sharing on my screen, but I'm not seeing it up, Tim.
Yeah, we can see it, but you
Oh, you
can't.
can.
Yeah, we can see it.
Gotcha. Okay, perfect. So where are we here? Thanks for your patience, everyone. I am a carpenter and not necessarily an IT person, so thank you. My name's Adam Larson, and I'm with Zoo House.
Adam, I'm very sorry.
Yeah.
We were able to see it, and
Yeah.
now we can see your presenter notes instead of the.
Oh, okay.
Let's give it another shot.
Okay.
No worries whatsoever. There we go.
Much better.
How's that?
Yep, perfect. Can you
Okay.
see your own notes?
Perfect. Yeah, I can.
Okay.
All right, perfect. Thanks again. Okay, so I just want to say thanks to the SSIRA for the innovation grant. So through this, we're exploring the renovation of existing buildings into high performance buildings by means of integrated envelope upgrades using a modular wall assembly. This is a 3-project case study. So I'd like to take a minute here and show you the work on project 1. Project 1 is a single family home originally built in 1953 as a 3,500 square foot bungalow. We've converted it to a 4,500 square foot net zero multi-unit residential building. Like many homes of its era, it had an aging mechanical system, minimal insulation, and construction methods that weren't designed with energy performance in mind. Edmonton's climate adds its own layer of complexity when it comes to buildings. We deal with extreme cold, long heating seasons, big temperature swings, so any retrofit requires a thoughtful approach to envelope. This project became a great example of how to transform older buildings into high performance ones while navigating challenges that we see in the city. The modular wall assembly became the go-to envelope for this building. So let's take a look at that. So our modular wall assembly offers a retrofit approach.
Adam,
Yeah.
I'm very sorry to interrupt you again. If you're advancing slides, we're not seeing the slides move. We're still in your first one.
Are you in presenter mode?
Yeah, I am.
There we go. Working now.
Yeah.
Yeah. Oh, now it's back. Now we can see your notes.
What the heck?
This is all good. This reminds me of being in COVID and having no idea how to make my technology work when I was done.
Yeah, I don't know. I only have the one screen open, so I'm a little bit confused about this right now. Well,
If the screen that you're sharing is the presentation, and then you move, if you click on the slideshow drop down and select presenter mode, and then put your presenter notes on the other screen and leave this one, should be okay.
all right. Let's see what we can do here. Yeah, it's
Okay, we can see your modular retrofit wall assembly slide now.
okay.
Yeah, and it's moving.
Okay. Give me one more second. Thank you. Okay. So the modular wall
Hold on. So
yeah,
your presenter, you open up another window with the presentation.
yeah,
That one is what we're seeing now. So I think your issue is you can show us this, but you can't see your notes, eh?
yeah, which is fine. Let's just go through it.
Okay. Yep, no worries at all.
Okay, so the modular retrofit wall assembly, the idea is that we wanted to build something that was versatile, nimble on site, didn't require a lot of relying on kind of unpredictable outcomes. We wanted something that could be using components to address the air tightness specifically within the installation itself. So, yeah, I'm going to have to so when it comes to the system, up on the site now, we have the gussets, the ledgers, and the tie-ins. So this is kind of the starting place of this wall assembly. First, we install the ledger. The ledger is, varies in size. Available components from LVL if we have external load on our wall to using a 2x10 ledger. In project one, we are using LVL gussets that are notched and hung off of the ledgers, and that determines the thickness of our wall assembly. Over on the slide on the right, you can see below the ledger is one of the critical tie-in points. So that's where we're taking our WRB back into the building to promote the continuity of our envelope. The window boxes, which in my mind are a really critical point of this wall assembly. Prefabricated off-site, ready for installation. They tie into the existing structure of the building. You can see on the left where we've left the stucco in most cases, except for just around the window opening. In this circumstance, the rough openings of the existing windows were shrunk by an inch, integrating the window box directly into the existing structure. Modifications around this window box could include not disrupting the existing window and installing this window box on the outside of the envelope. Seeing the window removed further down the line, not to disrupt residents who could potentially just remain living in the house while this assembly goes up. This is one of the key components that we're focusing on our prefabrication point of this assembly, which I'll get into as we get further into our upcoming projects. Here's a couple more pictures of the install of the window boxes. You can see even large windows like this house, where we're able to prefab these units and bring them to site and install them. Let's take a closer look at how they tie in with additions. One of the great opportunities that this wall allows us is to integrate additions to. We tie the top of our wall assembly directly into the base plate of the second floor addition. So the continuity, again, maintains throughout the building. So after our window boxes are in and our ledgers and gussets, we begin to start installing our vertical members. In most cases, we're just using 2x4 studs for this. So again, the intention of this project is to develop a modular system. So one of the advantages is that it's very nimble on site. We're not looking to bring in additional equipment for install. The window boxes are always manageable with 2 to 3 installers on site. We're playing around with potentially, which of these components are we prefabricating? The gussets, were entertaining the idea of using off-the-shelf members instead of the LVL, but structurally, we're really trying to dial this in and to optimize what items that we prefabricate that can really benefit the on-site production of this and the scalability. After the vertical members are installed, we jump onto our WRB. Here we can see Joel tying the top into our roof assembly, transferring our control line back into the roof, which in this circumstance was a hot roof. So the back of this gets spray foamed, keeping that continuity of our vapor line. One of the lessons that really came forward in this was our setup. You can see on the left where we set up our scaffolding. It really allowed us to move fluently along the job, installing some of the vertical members and then jumping directly on to the WRB and rain screen. After the WRB goes up, and really at the same time, we're stitching our window waterproofing on top of our WRB, at which point our windows can go in and then the rain screen can continue around this opening. Let's not forget about penetrations. This is always an area that you can never prepare for enough. Joe, I really liked your idea of having that flexibility in your system. We found with our electrical boxes, we were building panels, and depending on the exterior finish, the panel itself would allow for the depth of the box to be set in the wall. And of course, adding backing to properly secure our WRB around each opening. After all of our penetrations are sealed, we're ready for installation. On this project, we allowed for 8 inches of dense packed cellulose. In working with our insulator, we did back checks along the way, making sure that our cubic weight of cellulose was reaching our targets. And we had great results. You can see we didn't do any exterior sheeting on this and relied on the existing structure of the building for that portion of integrity. We were really happy with how this worked out. There was some concern about would the SIGA material act with enough resistance to allow the cellulose to be installed properly and inspect it. And we were quite pleased with the results here. So now that the installation is complete, we're ready for exterior finishes, soffit, siding. This building was dramatically changed. We started out with 7.8 air exchanges per hour, and our mid-construction blower door test yield 0.78. So we saw really dramatic changes in that. And I'm happy to report too, after our drywall was installed, we dropped down to 0.56. So we're really happy with what this wall assembly offers in terms of air tightness. So yeah, this is the building right before decks and exterior finishes. Yeah, my apologies for losing my notes. Hopefully I was able to capture everything I intended to. So yeah, thanks a lot.
Thanks, Adam. And no, that was great. And we'll draw more details out in the Q&A. So I'm going to let my friend Alex run the Q&A. Alex, I'll turn over to you in a second, but just again, another reminder, everybody, please use the Q&A widget. If you pop something into the chat, I will do my best to try to get it answered, but it's just easiest for us to keep track of what we've answered and what's coming in if you use the Q&A function. So Alex, I'll let you take it over.
Great, Tim. And I see there's at least 6 questions in there, and Joe and Adam, great presentations. You're going to be grilled on pricing and costing. But before that, Peter is going to ask a few questions. Ultimately, is probably going to dive really deep. But before that, let's zoom out a little bit. Some of the SSRIA motivation for funding both of your projects, one of the things was around replicability. And so, Joe, when I was out in Canmore talking with you and you're walking me through some projects, you sort of described, I think we went to 3 or 4 different ones, each being very different, of course, is the challenge. Adam, I haven't been to your project yet, but a fundamental piece of your proposal was to get better each iteration. So maybe can the two of you just speak to the idea that obviously these all can't be custom every time. You need to get more efficient. You need to get to sort of economies of scale. Maybe talk both HSS and Zoo House learnings to date, some of the ideas, maybe successes in terms of becoming more efficient, and then maybe some of the immediate barriers that you guys are seeing that you still have to get over. Maybe Joe?
Yeah, sure. Yeah, I think scalability is is important. And we certainly learn new things each project. The prefab side of things, there's stuff that you do, to reduce waste and to kind of streamline, that really is an assembly line. And so you got to think about it like that you're never, everything's ready to go and where it needs to be and all that sort of stuff. So that, speeds things up and makes things more cost effective. And then that ultimately is supposed to be saving you work on site, right? There is also this component of shifting, there's a lot more digital component on the front end. So we're shifting some of that labor, the time that we save on the back end, some of it gets shifted to the front end. And so the more that we can kind of reduce the front end time, and we had talked about that a bit, the kind of the digital workflow, there's certainly some improvements to be made there. And I think that has a lot of potential if we can address that front end and get that workflow so it's fast, and maybe some tools and stuff to make it less of a black box. Then, as we talked about, maybe that's a consultant that does that bit, and then other construction folks can hire this consultant to scan the building. And so then you can get a general contractor saying, someone comes to them and say, I want to do a retrofit. He can say, this would be good peer project. Let's get the consultant in to make us some plans, and we'll go ahead with that. So I think that that is the barrier as far as I'm concerned.
So interesting, Joe. HSS's approach is not only the physical, the prefab, the actual hands-on piece, but digitizing a number of those steps in the workflow to sort of speed that up. I'll be interested to hear from an employment perspective how easy it is to find those skills, and as you talked about, begin to separate those. But Adam, in your project, when you pitched it, you had an explicit iteration sort of through 3 projects where you went from site, you went into a partial prefab, and then ultimately the dream of sort of this rapid workflow offsite. How you're one plus projects in, how's that gone for Zoo House so far? What have you seen? What have you learned?
Yeah, I think that as a component-based system, we're really looking to see what each component delivers and understand what the value is of each component. So for example, take the window boxes. Say someone's not ready to do the full deep energy retrofit, but they need new windows. The question is our system adaptable to these partial renovations, so that, as most of us find, this is a big endeavor to take on the full gamut of a deep energy retrofit. So, as a component-based system, can we use this component in scale in a process that isn't necessarily all in one? So that's kind of one area that we're exploring in terms of the prefabrication and availability of the components themselves. But then also understanding what the value of each component brings to the table. Like, for example, the gussets, most of these walls, they're not really structural in terms of carrying a lot of load. We're carrying insulation and cellulose insulation. So there's a lot of adaptability in terms of our off-the-shelf materials that we're using. But the tie-in points are critical. And simply by installing them, we're getting that air tightness, like at really surprising quality. Like that's a dramatic change in quite a complicated house. So, if say you're starting with the windows, can we prefab those? Like the answer is yes. We're seeing that capacity. And then maybe looking at our wall system in the future as even an opportunity for a stepped installation where you're able to do it over a few stages. So that's kind of our exploration in terms of our components and what the true value to each of them are.
Interesting, sort of two different approaches, two organizations, two different approaches, but both really valuable and probably could layer on each other. If SSRIA is also interested, of course, in that market transformation across Alberta, and you two folks are sort of superstar organizations that are really pushing the envelope, literally. What do you see if, I mean, obviously HSS and Zoo House can't do the whole province. What do you see if, other contractors, other design builders were to do this kind of work? Do you see your solutions as something that could be easily shared, and other organizations like yours, do they have the skill sets? Do they have the ability to sort of take on this work? Or do you see significant barriers really in your two organizations even getting to this stage, never mind trying to have 10 other retrofitters do that? Do you see scalability at a province, with the work you're doing? Maybe
Yeah, I
Adam?
mean, certainly, yes, thanks. Certainly for these components, I see a great opportunity for scalability. Retrofitting windows, probably one of the most common things you'll hear at dinner conversations is, "Oh, I changed my windows out." It's like that's like a very approachable thing to do. Um, and so again, through the components themselves, like scalability is huge. I mean, we're not just looking to do every window in Alberta, like you said, and I would hope that we would see manufacturers even offer installations such as what we're suggesting here, where they allow for future envelope retrofits within their installation. So even if it's not a direct, like, block by block copy of what we're doing on our projects here, but the idea of a retrofit assembly on a component based level, I think is really approachable. In terms of other people taking on our wall assembly, we're using really off the shelf materials, which are really accessible to most people. And again, like, by installing the components themselves, you're achieving the air tightness. You're not needing a lot of understanding of what it means to have a super insulated high performance building. You simply need to know how to nail the component onto the wall. And that really translates to success in my mind, because there's not a huge gap in training people to understand the air tightness. The air tightness is a product of the installation itself. So, and that to me also aids in scalability. So,
Nice. So not rocket science. Joe, would you agree?
Um, I would disagree a little bit. I guess because so in we work in Canmore here, and we get guys that come over from other companies, and when you can be quite an experienced carpenter that shows up on our site, and when we go to do windows, they're going, oh, because there is a lot of other trades, or a lot of other companies are not thinking about air tightness much, and not detailing windows the way that we detail them to get there. And then that goes to other stuff as well. So, well, I agree, it's not rocket science. We're kind of, I think there's a shortage of trades in general, and people going into the trades. So I think as that gets worse, that's going to be a problem. And then you still, you need the companies that are doing this. We're both interested in doing this high performance stuff, but there's just a bunch that aren't. And then a byproduct of that is then that they're not really interested in air tightness, and they sometimes don't know the value of air tightness and our value, and all this sort of stuff. So I think it's going to require the industry to start caring a bit more. That being said, once they do, and I spoke a bit about that digital front end, and we get, that sorted out, I really see a lot of potential for other folks that to start doing this sort of thing. And I think nothing any of us is doing after the digital part is rocket science. It's just you just got to know and care kind of thing.
So lots of potential, and you guys are both optimistic, but there are still challenges in terms of further scaling. Maybe one last question. You both are not only looking at operational energy savings, but embodied carbon as well. I think, Joe, I asked you, does HSS get requests for lower embodied carbon retrofits? And I think the answer was no, generally they're not. But maybe just speak to, and you did a bit, Joe, in the HSS intro, but speak to a bit of why the embodied carbon is an important piece, either for HSS and or the clients, if you have them interested. And then Adam as well, how the embodied carbon fits into sort of your overall approach. So maybe Joe.
Yeah, so we use these wood fiber products no matter what. And the embodied carbon is just a nice side benefit of it. And like, when you sit down with a client and start talking about it, and they're thinking we're going to wrap the house in EPS or something like that, and you go, we're not interested in doing that, and go over the reasons why, and then go, we have this wood-based product. They usually come around pretty quick, and I think we're kind of lucky in Canmore that people appreciate this stuff a bit more. And then once you talk about the carbon component, like I did at the beginning, people get it, and that doesn't mean you have to use wood fiber, right? Like cellulose, there's this hierarchy of embodied carbon, and cellulose and wood fiber are really good, and XPS is really bad, and rock wool falls somewhere in the middle and is fire retardant. So there's something for everybody. And actually, one of the questions I saw was related to sound, and that's one of the things that I really like about this is it's wood fiber super good at absorbing sound. And so at the end of our retrofit, when you got whatever 9 inches of wood fiber on there, and you've gone from a double pane window to a triple pane window, there can be a train running through your backyard and you're not going to notice it, or at least not a fraction as much as you did before, right? So that's kind of one of these other benefits of wood fiber that also we can bring up when we're comparing it to other things, and the result is a super low embodied carbon project. So.
And of course, that's great in Canmore with the rail tracks running right near some of your projects for sure.
Yeah, exactly.
Adam, the embodied carbon piece is probably just integral to the way you guys operate as well. Maybe speak to that in your context, in your projects.
Sure. I mean, just these retrofits in general, like our project one, for example, this neighborhood probably would have typically seen a complete demolishing of this house and a start over. So just right out of the gate, we had a win in saving the foundation and the entire building. And then to leave, for us, like we left the majority of the stucco on the building. So again, another win. We're not hauling all this debris off to the landfill. It's remaining on the wall, and then all the way down to the material choices of insulating with cellulose, minimizing things like spray foam, for example, like using it in critical situations, maybe where we see a huge advantage, but not just like dousing the whole house in it. So it is important to us as a company to relay this conversation to our clients, but honestly, for the most part, we're finding people are coming to us asking us like, I want this. I want what out of these two options, what is the better use of our carbon footprint, and so we're really seeing the clients drive our projects in a lot of ways, which is really exciting to follow the lead of some of these great people with like good ideas about how to use their resources. So
Great, great philosophy, great work for both of you. And I'm gonna let Peter grill you in a second. And just a reminder to folks to put their questions in the Q&A button. You'll see down the bottom, and I see we've got at least 7 questions, and we'll try and address those. But over to Peter to grill these guys for at least 2 or 3 questions.
Okay, well, I feel privileged to be at the front of the grilling line here. Thank you very much, and especially, given we've got this great resource with these two guys and great projects. One of the things I'm obsessed with is the windows. And I want to ask you both about the potential. Like when I see windows installed in thick walls, and I think about the potential of water running down those windows and getting into those thick walls, it gives me the willies. And I am wondering, I my sense is that you could do a lot better job um, doing that in the panel shop or the prefab shop than you can out on the scaffold when the wind and rain is blowing at you and it's getting close to coffee time. Um, do you see the potential to in both those systems to pre-install the windows? So Joe, why don't you go first because you were presenting first.
Sure. I mean, it's yeah, we would like to start doing that. There is, to be honest, we haven't talked about, it's we're not close to doing it, but we do talk about, and then you got to start. The logistical thing is that then your panels need to ship vertically, I think. So we'd have to kind of sort something out there. And this is our second one. So I think we'd want a bit more swings at it because it is one of those things like we had mistakes on this second project and had to do some reframing of the panels. And, it was relatively easy to get out Sawzall, cut some things and shift things over. And, I'm on site for a lot of this stuff, but I'm not a carpenter. And I looked away for 15 minutes and they had it sorted out, right? If you have a window in there and then if there's something wrong and you got to move stuff, it's, a significantly bigger problem. That being said, we're interested, and I think it's, hopefully in not too long we will be doing it, but yeah, it's aspirational at this point.
How about you, Adam? What do you think with your pre-made window boxes? You wouldn't have quite the same scary situation as Joe. You would just install it on the existing RO.
exactly. I mean, and that's really the driver behind the component-based system, I think, is we're really isolating the window as its own identity. And as easy as it is to measure up what the new window is going to be, we're building that box, waterproofing it, and even seeing the window installed in a shop where the whole assembly can just be mounted. And I think ideally we would be removing the existing window after all that happened to minimize kind of the disruption as well. So I really am excited about our next 2 projects and to see how we can evolve this platform, not only for our use, but for industry as a whole. I think there's something here with how we're presenting these windows.
Great. And then one other question, or I have a million of them actually, but I'm gonna with the Joe, did I understand right that you were doing I had initially thought you were putting the cellulose in the panel before you built it, but you're doing it on site as well.
Yeah.
And you're are you having to leave very many holes to be able to do that? And what about the labor to seal those up?
Yeah, so we drill a hole in every. We have a 24-inch slip cavity on the panel, and we drill a hole in every one of those to fill it. And we do that because we just want to make sure that we're getting the right density in there. And because the panels open between the back of the 2x4 and the sheathing, it can come around into the next one. So that's why we have, tubes in 3 or 4 ahead of time, because there's material moving around there. And then, yeah, like you say, we come around and tape it afterwards. And the goal is always to do more and more of it offsite, if you can. We kind of like, this, because then we don't have to have a sheathing on the back, right? We have our wood fiber on the front, and then once the panel goes on and we blow it in, by not having that sheathing on the back, we get wood fiber in right to the existing sheathing, which I think will help with air tightness, because we have that poly on the very inside. So I think by dense packing, blown it in there, it's going to help with the air tightness as well. I think the first project, which was the first one, and I'm the guy on the hose for this stuff. It took 2 days to do. If we did it again, it would take less. And we're pretty good at taping up the holes. We have a spray can of glue now, and blah blah blah. So it's not super time consuming, but it is. It would. Then you get into that squishy layer that I know you're familiar with, and yeah, I don't know. It's I don't see us getting to where we're doing it offsite, that particular component of it, anytime soon.
That's interesting. Like I'm gonna I really think what you guys are doing is so important, to just grind it out and solve these problems and think about them and talk to each other and build on each other's ideas. I'm so happy to see this happening, and thanks to SSRIA for making it go.
Great. Well, thanks, Peter, for diving deeper in there. We do have looks like 8 questions, so try and get both Adam and Joe. First one, I think originally was directed at you, Joe, but Adam, you could probably answer as well. Just cost of upgrading the wall. So maybe just give a sense of, square footage, just rough dimensions of your project, and then an approximate cost, if you can. Maybe Joe first, and let Adam think about that for a second.
Yeah, and I can't answer that. I don't deal with the money much. And I will just say that, like, at this point, that's an easier number for people who are kicking out panels all the time to come up with, because they know exactly their costs more accurately. And when ours, it would vary a lot depending on the project. So I would say, give us a call, send us some pictures, let us know the scope of it, and we can come up with a number pretty quickly. But I think at this point, and Raf's not here, so I'm not sure. I don't know that we have a price per square meter, price per square foot number that we can share.
Gotcha. Adam, any more detail on that, or are you basically in the same boat at this stage?
I would say we're in the same position. I mean, yeah, I think to ballpark it, I mean, it really depends on the project and the layer of complexity, the shape of the building too. So I think that's, yeah, we're hoping to be able to speak a little bit more to that after our next two projects are completed. So.
Sure. And that's fair. And that, I mean, that fits sort of into the next question. It was again, question directed at you, Joe, in terms of does HSS do these projects in Edmonton? But I think this speaks to that scalability question. Right now, maybe both HSS and Zoo House, how close, I mean, how much scale do you actually have and how much ability to work outside your region? And, how are you maxed out now? Are you already sort of, or is there capacity even just with your organizations, never mind the rest of the province? Maybe just speak to that a bit. Joe first, sure.
Yeah, we've talked about this a few times, and we're in Canmore, and we've kind of figured that because our staff still live here in Canmore, so we've done projects in Springbank, which is just outside Calgary. Yeah, logistics of doing a project in Edmonton would be a little bit complicated, but I'm sure Raf wouldn't want me to say no. And we there again, like, we don't have to do everything, right? Maybe we consult prefab panels, send them up to Edmonton, and somebody else does some of the other work, and then we come up for a bit. But in general, we keep pretty busy, pretty close to home, which is why we haven't had to deal with those sorts of logistics in general.
Great. And of course, you did say in your slides that you're looking for a multifamily to sort of expand your expertise. What about you, Adam? You've got obviously the SSRIA 3 projects kind of on the go. What's the capacity for your organization to grow that, to scale that, and even outside of your sort of region?
Sure. I mean, interestingly, we've already had another builder try our assembly. We just were at capacity this last summer, and we had a project that was ready to go, and unfortunately we just couldn't fit it into our schedule, and we had another builder pick it up, take our drawings and execute it, and we're quite successful at it too. So I think we're seeing the flexibility of our system, and that this is adaptable. This is something that's palatable to people and easy to understand. So I'd feel really comfortable about shipping a set of drawings off to Joe and saying, like, look, we have someone interested in this. Here's what we're thinking. And, maybe there's adaptions along the way that by having other people take on this original idea, we're all going to learn from it, because they're going to come at it with a different perspective, maybe even a different approach in terms of how they mobilize or materials they use. So I'd be thrilled to see more people trying this out, and that's what's going to bring the cost down. That's what's going to make it more competitive for us and for other people to really get into it and figure this out together.
Yeah, and I guess I should just add, part of one of the deliverables that we have associated with IFIT and SSRIA funding us is writing a how-to guide, and I'm working on that now. And so when that's done, it's kind of designed to be a guide to walk you through the digital component, start to finish. So that guide, when completed, we could theoretically somebody should be able to do a project all by themselves. And again, part that scares them, maybe get somebody else to do that, but kind of do what you can and find somebody to do what you can't, kind of thing.
Fantastic. Of course, part of the SSRIA, we look for projects and folks like you that want to share that information. And clearly for people that end up are either on this webinar or end up on it, two companies that would love to share, and the market's at that stage where sharing is still very realistic. Great to hear. Looking at the next sort of questions 1 and 3, we're getting down to return on investment. And there's one question sort of comparing, I think, heat pump versus your guys' wall systems and envelope, and another just in terms of savings and return on investment, simple payback. Obviously, this is going to be challenging. You probably don't have that information down to the specifics, but I don't know if you can comment in general, maybe some of your clients that are trying to decide on a retrofit, a deep energy retrofit, and the decision to go with an envelope. I don't know if you have sort of thoughts on that as you talk to clients or you're selling these ideas.
Yeah, I
Maybe
can
Adam.
speak to that. Sure. Yeah, we did a feasibility study for this project where we looked at three different heating sources. So a gas furnace, an air source heat pump, and a ground source heat pump, all compared against a standard construction. So basically code minimum versus what our wall assembly that we ended up using. And the payback is there. I mean, and it's not only an economic payback, but we're seeing, you know, benefits of health, indoor air quality increased. You know, the clients of this project went with a ground source heat pump and our wall assembly, and the simple payback I think is sitting at about 18 years for the total upgrade. But you're not seeing any payback at standard coach construction and gas furnace. So, I mean, I think we need to start to consider how we look at real estate, how we look at these homes as an investment in all of our futures, you know, broader picture. So the payback is there and it is calculable.
Well said, Adam. Joe?
Yeah, so on our first project, I did just kind of a back of the envelope calculation, and it was, you know, partly because it was a gas furnace before and a gas furnace after, and that's the cheapest heating source at the moment. So and it was a smaller building, so the cost savings on the heating were not huge. So our payback on that one was, you know, I forget, it was, you know, 60, 70, 80 years, something like that. And it, you know, that doesn't tend to be how we market it. You know, I think comfort gets passed over a lot, and you know, occupant comfort and indoor air quality and all that sort of stuff is valuable. And I was at a different meeting, we were talking about that, and I kind of concluded, like, you need to translate the word comfort to what people understand. And so if it's, you know, the homeowner that you're talking to, then comfort works as the word. You know, if it's affordable housing, then maybe it's more of a dignity thing, in that these are maybe older people, people who, you know, don't have a lot of money, that are having to live in affordable housing units, and there's some dignity in that being a comfortable place for them to live. And then for people who are, you know, maybe extracting rent from a building, it translates to vacancy, because, you know, I've been in a number of apartments that I liked but were cold and noisy and uncomfortable, right? So I think there's, you know, a more complex economic argument than just the simple payback, and I think, you know, it's important to focus on all that stuff as well.
Great. With a few minutes left, still have a few questions, and there's a few that are specific to the technology and the approach you guys are taking. One of them here is pre-built panels versus building on site. Do you notice a difference in installation time? Is it more effective utilizing experienced carpenters for the pre-build, using less experienced trades when installing on site? Maybe just some comments on that piece. Maybe Joe first.
The prefab is kind of, you know, the experienced carpenters get a little bit bored of that, because it's kind of paint by numbers, and that's what allows it to go so quickly. The the site part of it, it gets a little more involved because you're putting panels on and everything needs to be plumb and square and closed up well and all that. So you definitely need skilled carpenters for that part of it. And this site that we are on for the second project is a super narrow site, not a lot of room. So prefab there was certainly beneficial. And in other projects that we're planning for, we're kind of doing this because it works. People didn't come and say they wanted a pier. They said, we want to do a deep energy retrofit. And then we said, all right, we're going to prefab these panels because it's better for us, right? Just because of site constraints and stuff like that. So maybe that's not the case in all circumstances, but certainly in a lot of cases we prefer it just because it's less complication on site.
Right. Adam, thoughts?
Yeah, I mean, I think I don't want to take away from like the value of skilled labor, because I think it's really important to have people who understand the methodologies of construction from the ground up. I think that's like something that we should hang on to as a society and not lose that as a training idea. But I think in terms of scalability and production, of course you're going to have higher production with more skill, but then you're going to have a little bit of more of that upfront cost. So I think it's important, like as we manage these projects, understanding the cost value of labor and production and finding that sweet spot that's gonna deliver the best outcomes. Again, I think our system's quite simple. If you understand how each component gets installed, I think you can have a fairly low skill level with proper oversight and inspection along the way. So I think I'm seeing a huge advantage of this system. One thing I really like is like we're not needing assistance necessarily from cranes and like large staging grounds. We can slide into hard to reach spaces and upgrade envelopes with minimal impact, and that's really been a focus for Zoo House. Just seeing a lot of the neighborhoods in Edmonton, it's hard to find a spot for a picker and to find a spot for the truck and trailer with the panels on it, in my experience, to mobilize in that way. And there's ways around it for sure, and industry's figuring that out, but we wanted to focus on kind of like a in and out methodology where we're impacting residents as little as possible. So that's kind of and I think that's going to happen with some knowledgeable staff on site too, who understand how the system goes together. So
great. Well, there's still a number of questions. I think 3 of them are specific questions. Ria, a 1953 bungalow with no vapor barrier. Questions around the glazing performance as you add your wall structure. We're going to run out of time today for that one, and so I would suggest both reaching out to Joe, reaching out to Adam. I think both their websites are in the chat. I think Tim has put them there, and if not, contacting Retrofit Canada and Tim, I'm sure, can help direct you to get answers on those, and of course Peter as well. But maybe the final question is really around collaboration between HSS and Zoo House, the learnings coming out of the SSRIA projects, but ultimately your 2 organizations as really leaders in the Alberta market. Do you see an opportunity? And in fact, I'm pretty sure I know the answer. You're already sharing some of your learnings. Maybe speak to that as being at least 2 of the pioneering organizations and where you see this going. Maybe Adam first.
yeah, I mean, I think I touched on this a little bit earlier on. The value of learning from projects like what Joe's got underway in Canmore. Just even looking at your pictures, Joe, I'm seeing things. Oh, how could I use that adaptation of your pre-installed hose into the assembly for insulation, for example. Maybe we could minimize some of our penetrations for insulating based on what I see you presenting. So I really appreciate kind of the wisdom of experience. Again, as many ways as we can come at this, we're gonna draw out other methodologies that are adaptable to our own unique situations. So yeah, I think that's kind of, I'll stop there. I think you could go on for a long time on this one. So
Yeah, and I agree. Like, we meet with the Retrofit Canada folks, and it's a bunch of guys bunch of folks like us. And you know, we present details and, you know, ask questions and make suggestions. And you know, it is interesting. You can look at some of these challenges, you know, 100 times, and then somebody who's just wandering by makes one comment and a little light bulb goes off, where you see a picture of someone else's project and you go, oh, that might work here. So it's definitely, and it is very much the mood that is kind of a rising tide floats all boats. We need more deep energy retrofits. We don't, you know, it doesn't seem like people feel like they're competing against each other. They're more interested in just, you know, generating more retrofits overall, right? That's what we need to do.
Fantastic, Joe and Adam. The innovation, SSRIA is excited about the innovative work, and of course, both your projects will be showcased up on the SSRIA website, and as some of the documents and outcomes of the project to be shared more widely. And of course, case studies. I'll turn it over to Tim. Will ultimately be on Retrofit Canada, and thank you, Tim, and Retrofit Canada for including SSRIA in these webinar as well. Over to you, Tim.
Thank you so much, Alex. Thank you, Adam and Joe. Peter, thanks again for joining and helping us dig into the projects. I apologize to those of you whose questions we didn't get to. That's what happens when the conversation is rich and the questions are specific and we have experts that can answer them. So as Alex said, do feel free to reach out to Adam and Joe. And there was one question about somebody who's having difficulty finding anybody to do the retrofit. And they're hoping to get some concrete advice. And I don't know what your situation is, what region you're in, but I do know that there's just no way around the fact that we're still starting. There's like we can't just wish experienced builders like Adam and Joe and Peter into existence in every part of Canada where there's homeowners that want these projects. So I wish there was. If there was, we'd be further along. But like this on the site learning with support from organizations like SSRIA, like it's taking the time it takes. It's time well spent. We're going to keep seeing more. I know Adam and Joe are going to keep doing some awesome projects. We look forward to getting the current projects in the library and the future projects. I believe they promised that we get all of them, and that's one at a time. So thanks, guys. Thanks, everybody, for joining. Thanks, everybody, for the questions, and I hope you have a wonderful holiday season. Our next webinar will be scheduled sometime in 2026 in the first quarter there. So just follow us on our social media, LinkedIn, or our website for information on that. Talk to you soon. Have a great day.